Let us get started with ABC of trigonometry to solve some real difficult test problems. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. This series is for the students who want to start learning about trigonometry. So we are beginning with the primary trigonometric ratios and working on right triangles at present. In the last video, we understood what the primary trigonometric ratios sine, cosine and tan are, and in this video, our focus will be on finding the angle in the triangle and thereby solving a right triangle as a whole. So the topics which we will take up are to evaluate trigonometric ratios for an acute angle, understand inverse trigonometric functions, find angle in right triangle. How do we choose which ratio is correct to find the angle? That is choice of correct inverse ratio. Multiple step questions will be solved using many triangles, and then we'll have some applications and practice test questions. The questions which we are going to discuss are kind of like this, just to evaluate a trigonometric ratio for a given angle. It could be any angle. How do we measure angles? Using tan or sine or cosine inverse ratios, correct? With given some problems, as you can see. So we'll have about 10 questions, as you can see here, and based on these learnings, there'll be 10 practice questions for you. I hope it sounds interesting. Let us see how good it is with the help of these videos. Also remember one thing, that you can always learn directly from me by sending an email on the address given. Most of my students are right there on top of their class getting awards and scholarships, just as Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now let's begin with the very first thing, and that is, how do we really evaluate a trigonometric ratio for a given angle? So here are 6 examples for you. I'd like you to pick up a calculator which has sine, cosine and tangent on it. So you will also see inverse of these functions, and I'll see how we can use them effectively. So set calculator to degree mode to calculate each ratio. And then once you find the number, round it to 3 significant figures. So this is an exercise which you have to do. Round the answer to 3 significant figure. Perfect. So evaluate sine of 32, evaluate tan 63, cos 27, tan 12.5, sine 140 and tan minus 38 degrees. So just get used to your calculator. How do we work with these ratios? That's the whole exercise, not a big deal. Perfect. For some of you who are using it for the first time, it's important to set the calculator to degree mode, right? To calculate these, since we are giving all the angles in degrees in this particular video. So sequence to be followed is that you have to press the sine key and then the number 32 degrees, 32, and then equal to sine. When you do so, you see on the screen 0.5299. Rounding it to 3 significant figures will give you 0.530. So that is the 3 significant figures, correct? For tan, we have this key tan, press the number 63 and then equal to, you get 1.9626. rounding it to 3 significant figure will give you 1.96. So understand what is 3 significant figures so that you can actually get the exact answer required, right? Rounded to 3 significant figures. Perfect. And that's kind of important from many test point of view. Okay. So here are a few examples done for you. You can only check your answers for different angles. Did you do the right rounding? Did you press the right keys? So that is warm up, right? Because if you don't do this correct, then you may not get any correct answer. Perfect. So now I hope your calculator is well set to start working with it effectively. Now, we learned that that's the kind of right triangle which we deal with. If you're interested in angle A, the side opposite will be C to B as shown here. In this case, it is of 4 units length. And the adjacent side AB is 3 units length. Now the idea is, how do we measure angle A? We know what sine A, cosine A and tan A is, but how do we find angle A, right? Now, you also notice that here we are only given two sides. And which two sides are given to us? We are given the side which is opposite to angle A and adjacent. So if that is the case, then you can only use tan ratio, because tan is the ratio of opposite to adjacent, correct? So it all depends on what is given to work with. Okay, so we say that tan A is equal to opposite over adjacent, which means 4 over 3, right? Now, you can always calculate this number in decimals, but the idea is, how do we find A? Now, A is found by taking inverse of tan, right? So now, take inverse of tan. Which is like tan inverse on the calculator. How do we do it? There is a shift key. You can press that tan and then figure it out. But to write it, we write measurement of angle A is equal to tan inverse of 4 over 3, correct? Equal to. So that is how we do it, correct? Now, why did we take tan? Because the sides given were opposite and adjacent. And that's why we took tan as our ratio. Is that part clear to you? Now, when you do that, what do you get, right? You hold your calculator, put it in degrees, right? And then do this. Perfect. So, some of you who might be struggling at this stage to see where are these keys and how to work with them, then see, this is a sequence to be followed. So, first press the shift key and then tan. So this, when you do the combination, one after the other, shift then tan, will actually result in tan inverse, right? And then you do 4 divided by 3, bracket closed, equal to. You get the idea. So once you do that, then you get the tan inverse of 4 over 3. And the number will be shown on the screen as 53.13010.235. Now, many times we round it to 3 significant figures, but depending on the question and requirement, it could be 1 decimal place, 2 decimal place, or a whole number. Perfect. So, accordingly, you can find the measurement of the angle. So, in this particular case, we just figured out that the angle A is 53.1 degrees. Makes sense? So, I hope you have understood how do we use calculator to find this inverse, right? So press the combination of shift and tan to get tan inverse. Perfect. As shown here, once we get tan is 4 over 3, then the measurement of the angle is tan inverse of 4 over 3. And the sequence to be followed is shift tan 4 divided by 3, bracket close, equal to. You get this number, write it down, and then round it to the required decimal place. Perfect? Okay, great. So let's continue with this. So now you understand that you could use tan inverse to find the angle, as we did it in the last example. But you know what? We have sine and cosine. You could use them also, right? So how do we use the others? That is what we'll see now. So I want to find the angle A, but can I find using cosine? Why not? See how. Let us say that we want to use cos, right? So what is cos A? Cos A is adjacent over hypotenuse, means 12 over 13, right? 12 over 13. So we can say that the measurement of angle A is equal to cos inverse of 12 over 13. You get the idea. So this time I use cosine. I'll get my result correct. Use your calculator, write down your result. Perfect. The next one I will do is using sine. So if I want to use sine, then which side? I have to look at the opposite side, which is 5 in this case, and the hypotenuse, which is 13. So I'll write that and say that the measurement of angle A is sine inverse of 5 divided by 13. And I'll get the same answer. Verify it. It's a good time to verify. Do you get exactly the same answer? Perfect. Of course, you know how to use tan now, correct? So you could find it out. Perfect. So try it out. You could use any trigonometric ratio out of these three. So either sine, either cosine, or tan. It all depends what is given to you. In this triangle, all three sides were given to us, so you could use any one of them. Perfect. So here is now a practice example for you. I would like you to pause the video and answer this particular question. It says find the measurement of angle theta. So angle theta is right there. So highlight where the angle theta is and you see which sides are given to you. So now can you tell me which sides are given to you related to angle theta? So you see we have the hypotenuse for sure and we had the adjacent side. So since these two sides are given to us, it is the ratio of cosine which we have to use. So we can say, well, cos of theta should be equal to the adjacent side, right? Let me write first here, adjacent over hypotenuse. And in this case, it is 5. So it is 5 over 13. And therefore, theta is equals to cos inverse of 5 over 13. Makes sense. So now go back to your calculator, press the shift key, the cosine key, and then 5 divided by 13, close the bracket, equal to, what do you get? Well, I get 67.3801, right? So 3801. I'm going to round this to one decimal place and write it as 67.4 degrees. Is that clear? The answer is in degrees. Perfect. So that is how we found this angle theta. Get the idea? Simple, right? I hope you got the same answer. Now, let's take up the next question. Now, this exercise is meant for you to do along with me so that you really understand. So, in case you're falling behind, you just pause the video, okay? Now, example 4. Find measure of angle P. Now, we are given a triangle PQR. PQ is 8 centimeters, QR is 6 centimeters, and the angle PQR is 90 degrees. Okay, so we can make a right angle triangle first. Okay, so we just made a triangle. So angle PQR is 90 degrees. That means this particular point, which is at right angles, happens to be Q, correct? That is 90 degrees. So we're taking care of this part. Now, we're given that PQ is 8 and QR is 6, right? So let's write down 8 and 6 here. And PQ is 8, right? And QR is 6. Makes sense? So we got our this. And we now want to find the angle. Which angle? Angle P, right? We want to find this angle P. So which trigonometric ratio will you use? That is the major question, and that is always a major question. So now you can say that we know two things about it. One, we know the opposite side, right? Right? We know the opposite side. And then we also know the adjacent. Right? And this ratio is what? SOHCAHTOA you want to use, right? Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. And clearly, since we are given opposite and adjacent combination, we should use tan. Makes sense? Correct? So we are going to say that tan of angle P is equal to 6 over 8. You could simplify this if you want to, but not necessary, right? So I'm just writing 3 over 4, but not really required. And now we can do measurement of angle P is basically tan inverse. So now you use the inverse key and find what 3 over 4 is with tan inverse. So go back to shift key, press tan 3 divided by 4 bracket close equal to, and you get 36.86. 869 in fact, so I'm going to round it to 36.9 degrees. That is 3 significant figures or 1 decimal place in this case. You get an idea. So I hope it is absolutely clear how do we figure this out, correct? So you could actually extend it and find the other angle. Well, the other angle will be 90 minus this, perfect, or you can use ratios. So I hope it is clear, right? Let's move on, take up the next example, which is find the measure using different ratios. Oh, different ratios means, well, it is given to us that in triangle OPK, find measurement of angle K using cosine ratio. So the angle K is right there. And we have to use cosine ratio. So we'll say cos of K is equal to what? Now cosine ratio, as you know, is adjacent over hypotenuse, correct? So adjacent is 2 and hypotenuse is 3, so we write 2 over 3. So we can say that K, angle K, the measurement of angle K, is equal to cos inverse of 2 by 3. So let's do shift cos inverse 2 divided by 3 bracket close equal to. Follow the sequence, okay? Follow the sequence, and so that won't be a problem. So let me now round the answer to. So measurement of angle K is 48.189. So I'll round it to 48.2 degrees. Is that clear to you? Did you get the same answer? Perfect. Right, okay? Now, this is part A for us, correct? Now part B, which is in triangle OPK, find theta using sine ratio. So this time we have to use sine ratio. So if I use sine and we have to find the angle theta, which is right there, then the opposite side will be 2 and hypotenuse remains 3. So sine theta is 2 by 3. So theta equals to sine inverse of 2 by 3. Correct. So go back to your calculator, shift sine inverse 2 divided by 3 bracket close equals to. You need to practice 41.81. So I could write this as 41.8, right, in degrees. So that is how we are going to do it. Perfect. So we found both the angles this time, 41.8 and 48.2, right? Now, can you check whether these are correct answers or not? So how do you check this? This is also important. Let us check. So add them, right? So what is 48.2 degrees plus 41.8 degrees? Let's add them. And what do we get? 0.2, 0.8 is 0, 1 there, so 0, and we get 90 degrees. Do you see that? So that is correct. So we get theta, angle theta plus angle K is equals to 90 degrees. And that is what is expected, correct? So when you add these angles, you should get 90 degrees. And that's what we got. Perfect. So that clearly indicates that our calculations are perfectly fine. We are on the right track. Perfect. Okay, great. Slow and steady start. But we are now looking into real questions which you see as difficult test problems, correct? So from here onwards, we have some very difficult questions coming up. I hope you're ready with it, right? Ready with your calculators, correct. So we'll now find the trigonometric ratios for coordinate point. As shown here, we have a circle with radius 5. A point on the circle is 3, 4, right? The question is, point P, 3, 4, lies on the circle with center at origin. O is shown in the figure. Radius OP makes an angle theta with the horizontal x-axis. Find the measurement of angle theta in standard position. So what is standard position? Standard position means the angle which is made with the positive x-axis. I should say counterclockwise, right? So counterclockwise angle made with positive x-axis. Correct. Now, in this particular diagram, let me enlarge this particular diagram. So we have basically, I'm just enlarging this diagram here. So what I'm doing here is kind of like this. I'm enlarging this. Okay. So we are given a point P. This is O and that is Q. So this forms a right angle triangle. And the sides given to us should be what? Point is 3, 4, right? 3 is along the x-axis, right? And 4 is along the y-axis. And this is the angle theta which you want to find. Clearly, tan, right? So we have to use the tangent ratio which is opposite over adjacent. So we can say tan theta is 4 over 3. And theta is tan inverse of 4 over 3. So now go back to your calculator. Shift tan 4 divided by 3 bracket close equal to. What do you get? 53.13. So round it to one decimal place. Makes sense? So this is the exercise we are repeating over and over with different examples. But that is how it is, right? Once you get expertise of using effectively your calculator, understanding the questions, you can solve such questions. This is not an easy question. Okay? Perfect. Now, as an added exercise, can you find the angle which it makes with y-axis, right? So the question is, find angle which radius OP makes with y-axis. Is that clear to you? Perfect. It's not a difficult question. Just write it down. Here is question number 7. So let's get back to some of the basics. We now need to find the acute angle for the given trigonometric ratios. So tan theta is equal to 1. So what is theta equals to? Just use your calculator and say theta is equals to tan inverse of 1. And when you do that, you'll get your answer. For the next one, it is theta equals to, we are given sine theta is 0.7543. So it'd be sine inverse of 0.7543, correct? Get your answer. Cos theta is half. Theta is equals to cos inverse of half, correct? Get your answer. So that is how you could actually find the answer, right? So if there is nothing mentioned to here, like find the acute angle for the given trigonometric ratio. So when I do tan inverse of 1, I get 45 degrees. Now it also makes sense because tan value of 1 looks special, right? It means opposite and adjacent sides are equal, right? So that will happen if we have isosceles, right triangle, correct? Correct? So that is how it is going to be. But this is a weird value. We can use the calculator. Shift sine inverse, right? And the number 0.7543, okay? And then press equal to 48.96. So I'll write 49 degrees. And the last one is a special triangle. We'll see special triangles in next video. But here, let's find this answer. Cos of half 1 divided by 2 bracket close is equal to, as expected, 60 degrees. Correct. So that is how it is. Perfect. Let's move on. Take the next example. So I hope things are absolutely clear. Very easy, right? Now this is a very important question. It says, find the angle for the given trigonometric ratio without calculator, right? So this is without calculator. Justify your answer. So we have tan theta of 0, sin theta of 0 and cos theta of 0. These are the three questions. What are the angles which make these 0? Very important to understand. So as you know, these ratios are what? Well, sine basically is the ratio opposite to hypotenuse, right? Opposite to hypotenuse. Cosine is adjacent to hypotenuse. Tan is opposite to adjacent. So when I say tan theta is 0, that means opposite side equals to 0, right? Numerator has to be 0. So for which angle will this opposite side be 0? We're looking at a triangle kind of like this, right? Let us see. This is angle theta for us. So that can happen if I just bring it closer, right, to 0. Do you see that? So as it comes down, right, in this particular fashion, the triangle closes. What happens? Well, it becomes 0. Makes some sense, right? So opposite side becomes 0. That means, I should write, that means, implies, theta is equal to 0 degrees. Makes sense? Now, when sine theta is 0, then also it is a ratio of opposite to hypotenuse. So opposite side is equal to 0. That implies theta is equal to 0. Same as tan. But for cos, it is the adjacent side, which is in the numerator, right, for cos. And adjacent side equals to 0 means this has to reduce, correct? So in this case, what is happening? I mean, it has to increase, correct? So for this, theta should be equal to 90 degrees. You get the idea. So sine and tan are 0 for 0 degrees, but cos is 0 for 90 degrees, correct? Let's move on and now solve a test question. Now this one is a multi-step question. We are given two triangles. Both are right angle triangles given to us. You need to find the value of x and y. Perfect. So till now, you understood how to use your calculator, when to use which ratio, how do we solve right triangle, and now we are going to solve two right triangles simultaneously. Are you there with me? Perfect. Okay. So how do I find the values? One by one. We are given an angle, and in this right triangle, we are given 90 degrees and 50 degrees. So we have to find the side opposite to 60 degrees, right? So think like this. So, and on the other side, we are given only one angle. Okay, so that may not work, but this can work, right? So, okay. So side opposite to 60 degrees is x. So we can begin with, and the hypotenuse is given, right? So we think like this. Opposite to 60 degrees is x, right? And we are also given hypotenuse, which is 50 degrees. So that is a thinking process. You understand? That is a thinking process. Nothing to write, but that's just for you to show, right? Okay. So we can say SOHCAHTOA, right? Sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. When you begin with trigonometry, many times we have to use these ratios. We don't remember them, right? So what to do? Write it on a piece of paper, see. Okay. So that means I should use sine ratio, right? So I'll use sine of 60 degrees, which is now equal to opposite side of x and the hypotenuse of 50. And that tells me that 60 times 50, 50 times sine 60 should give me x. So cross multiply, right? Use calculator. So 50 times sine 60 is equal to 25 square root 3. So let me write decimal value. I know this is approximate, so we'll round ultimately the answers to whole numbers. So we get 3.01. Let me round it to 3. So we have the value of x, which can be rounded to 43.3. Is that clear to you? Correct. So we got x. Now, since we know what x is, we can find y in the second triangle, right? So now let's look into this particular triangle from 70 degrees. What do you notice? Well, from there, we notice that y is opposite side and we know x now adjacent, and therefore we can use which ratio? Tangent ratio, right? So tan of 70 degrees is equal to y over x, right? We want to find y, so y equals to x times tan of 70 degrees. X is known to us. You can use this value, right? Or you can use 43.3, not a bad value, right? And tan 70. Use calculator. So we have this 43.3 already in the calculator. Just multiply by tan of 70. You get the idea how to work effectively, right? So this side is, let's do it, tan 70. We are multiplying this by 43.3. And we get 118.96. So this side is 119 units. Do you see that? So that is how we can actually solve this particular question. Get an idea? So multiple triangles can easily be solved as shown in this example. Perfect. I'd like you to pause, do it yourself, and gain confidence of doing such questions. The whole idea of doing previous examples was to get to this stage. Okay? Question 10. So multiple choice question seen in many test papers says, in a right triangle ABC where A and B are acute angles and sine A is given to you, find cos B. What? And 4 choices. Okay? So let's make a triangle and try to understand what is given to us. So we are saying that the sine value is given to us for angle A, right? Let's say in a right angle triangle where A and B are acute angles. So that means A and B. Makes sense, right? They are acute angles. And sine A is 0.25. We have to find cos of B. So sine A really means we are given the ratio of which two sides? This over that. And what is cos B? Well, cos B is also BC over AB, right? And sine A is what? It is also BC over AB. Do you see they are the same thing, correct? So it has to be same. And this is called cofunction identity. So this is a spiral test. So from the previous learnings, you know this actually. And so you know the answer is option A. It's always good to review what you learn. Perfect. Now, we have come to an end to our practice. End of our examples. It's time for your practice questions. I hope you find it interesting and useful, right? And in case you have doubt, you can always contact me on the email to learn more. So now, are you ready for the practice test questions? Let me take them one by one. Here is question number 1. Very simple. Just as we began, evaluate. So start practicing how to use a calculator in degree mode. Round your answers to 3 significant figures. Perfect. Question number 2. Find the measure of angle theta. Now, we're given all the sides. However, the question specifies use tangent ratio to find theta. So when you do these questions, you're reminded of writing SOHCAHTOA, right? Sine is the ratio opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent. Since you have to use tangent ratio, you're looking for that, correct? From angle theta, which is these two sides. Make sense? And then inverse. Question 3. You're given tan theta equals to 0.5, solve the triangle. When we say solve the triangle, then find all missing angles and side lengths. Make sense, right? So do that. It's a slightly difficult question, but I hope you get it, right? Otherwise, you can definitely write down to my email. We are going to take these questions up soon. Question number 4. Solve the given triangle means find this angle, right? Find this angle and this side. Perfect. Similar to previous question, correct? So let me do this kind of a question once for you. We have similar triangle done earlier. You can begin with finding the angle theta, knowing the opposite side, and see, this is your hypotenuse. You say tan theta is equal to 8 over 10, right? So theta equals to tan inverse of 8 over 10. So theta is equal to what? Use your calculator. You may round it, right? Okay. So shift tan inverse 8 divided by 10. And you get 38.659. So we'll write 38.6 degrees. When this is 38.6 degrees, then the angle D is what? So the angle D, which I could write here as 90 degrees minus 38.6. Makes sense? So we do minus from 90 degrees and we get 51.34. Let's write 4 here, right? Because we took 38.6, right? So, okay. So we get this angle. Once we get the angle, we have to find the sine. Let's say this point is F, D to F, right? Now D to F you could find using Pythagorean theorem, right? So DF, EF is what? EF is equal to square root of 10 square minus 8 square. This is one way of doing it, which is definitely 36 and 6, right? But the other way could be that once you find the angle, right, with tan inverse, then you could use your ratio, correct? So, and then figure it out, right? So we can say that since it is adjacent side, let's use cosine this time, okay? Cos of 38.6 is how much? From this angle, this becomes adjacent, right? So let's call this as x will be x over 10. And that implies that x is equals to 10 times cos of 38.6, right? And that will give you the answer as 6, rounded. Perfect. So you could use trigonometric ratios in this fashion. Perfect. Okay. But you could also use Pythagorean theorem. That's what I wanted to show you in between. Perfect. Then we have example 5, and this is kind of complicated, taken from our test papers. Now here we have a triangle in which AC is 125 meters, angle A is 25 degrees, and C is 30 degrees, as shown here in the diagram. You need to find the height h in the first example. 4 choices are given to you. Which one is the correct answer? Now the same figure is also used for another multiple choice question here. And in this case, we have to find the length D to C. So based on this triangle, you have to solve it to find both H and DC and then answer these two questions. Very important test questions. Perfect. This is a serious trigonometry now. Correct? We started with basics, just figuring out how do we use calculator to find what is sine of 63 degrees, right? Now see where we are within just 10 minutes. Perfect. Here's question number 7, a great word problem. I'd like you to pause the video here Read it. An airplane, when flying at a height of 3125 meters from the ground, passes vertically below another plane at an instance when the angle of elevation of the two planes from the same point on the ground are 30 degrees and 60 degrees respectively. Find the distance between the two planes. You get the idea. So these are two airplanes. Do you see that? We need to find this distance between them. Very interesting question. Question number 8. Find the value of x. It is similar to previous question but not with a word problem. You get the idea. Well, in the last question we were given this height. Okay. Question number 9 is a complicated 3 triangles given to you, 3 right triangles. From where to begin to find the unknown values? We need to find the value of x. You get the idea? Have a close look at this and then try to solve. So definitely we have to begin from triangle ABC since we are given the side and one angle. So we can find the opposite side and move forward. Now at the end we have exam practice. So in this part of trigonometry we have come to the first baseline where we have understood how do we work with right triangles, how do we find angles. And earlier we learned about so many other properties of triangles, including similar triangles, congruent triangles, and based on that, there are 4 questions. So this is what I call review, right? So review your concepts. So go through these 4 questions. They are from past test papers. I hope with this, you kind of understand where we are getting into, right? And in case you want to learn from me, you can also send an email at this address. So we'll end at this stage here. I hope you find this exercise interesting. So we moved in from very basic concepts to something which was kind of more complicated than expected, right? So that is how we learn. In the next video, we will see applications of tangent ratio, sine ratio, and cosine ratios. I hope you are finding this series interesting and useful. Feel free to write your comments and suggestions in case you really like my videos. Also subscribe, and you can also learn directly from me by sending an email on the address given. Thanks for your time and all the best.